Hi, my name is Patrick and I'm a PhD student in astronomy and geology at the University of St. Andrews. And today I want to tell you a bit about my research on lightning on the young Earth. So this is a nitrogen atom. I mean, of course not really, but for the purpose of this video, just imagine this blue ball is a nitrogen atom. Nitrogen is really important for life. It is, for example, in our DNA, and we also spray it onto our fields as a fertilizer. And luckily, there's plenty of nitrogen around us. 80% of the air we breathe in is made of nitrogen. Unfortunately, nitrogen in the atmosphere is not really accessible for life because it is stored in extremely stable N2 molecules, and we can't just easily break them apart. However, life found a clever solution to this. There are bacteria living in the soil that breathe in these N2 molecules, and they produce other forms of nitrogen, such as ammonia. But if we now look 4 billion years ago on the early Earth, these bacteria weren't around yet. So we need a different way to break apart these N2 molecules and make them available for the origin of life. And what giant source of energy was around both today and on early Earth? Lightning. With the power of one lightning strike, you can power a normal light bulb for more than 5 years. That's where my research comes into it. In the lab, I produce my very own little lightning strike. I know, it looks a bit underwhelming, but believe me, it does the trick. We fill the flask with gases that were around on early Earth. That's nitrogen and CO2. The spark breaks apart the N2 molecules and produces nitrate, which then accumulates in the water at the bottom of the flask. And nitrate is nothing else but the fertilizers we spray onto our fields today. I hope I could convince you that lightning is not just fascinating, but it was also very important for life to thrive on the young Earth. Enjoy the rest of your day at the Global Science Show. Goodbye.